Hello, students. So today is our second class. So in the previous class, you have learned about the signal systems, what are the various types of processings, and the classification of system. That is continuous time system as is signals and discrete time signals. Okay, two types of signals. So that's all about the studies topics. So and the overview of this topic. So here we are going to learn about the next topic, that is the components of digital signal processing systems. So what are the components are involved in the digital signal processing? So let us learn or understand through an block diagram. Okay, next, block diagram of a digital signal processor. Okay, so this is the basic block diagram. So by seeing the block diagram, don't get scared. Okay, so this is nothing. You have understand the lot of you have understand the concept. Okay, I will give you the one by one the topics. Just take down the notes, so you will get that knowledge better knowledge about the each and every components of the DSP. Okay, so here I have just read out it, and I have it explain it one by one. Okay, first it's we are giving the analog signal. Why we are giving the analog signals? So in this today's world, most of the signals are analog in nature. Okay, so analog means it's a continuous time signals. So we want to get the knowledge why we are converting from analog to digital signals. As it is, okay na, why we are converting from analog to digital signals? Because we are converting from analog to digital signals, we will get the information from the devices. Again, that digital signal is converted to analog signal. So we are processing or we are using it as an analog signal. Okay, so this is the block diagram. So what are the components? That is, first one is sampler, hold, analog or digital converter, analog to or analog to digital converter. So that is a digital signal processor. This is the processor major thing. That is a digital to digital converter. Next, it's a digital to analog converter, and yet again it is converted to the analog low pass filter or processed analog signals. Okay, so first thing is the analog signals. So analog signal is given to the sampler. What is the, just take down the notes about the components one by one I am telling. Okay, what is sampler? Sampler means it's a process of converting from analog signal to discrete signal is known as sampler. Okay, so then the sampler signal is given to a hold signal, because we should convert it from analog to digital signal so that we can gain the information about that signal, right? So we are using that sampler. So the sampler, the analog signal is normally converted to the digital signals by using the sampler. So we will get the discrete signal. Okay, so the discrete signal is given to the hold signals. So why we are given to the hold signals, and what is the proper actions of the hold? Okay, so the hold signal is normally used because it will gives as an input for analog to digital converter. For converting from analog to digital, it will gives as an input for the discrete signals. Okay, so we will get unsampled signals. The sampled signals will given to the analog to digital converter. So it will give an input to the discrete signal. So the discrete signal gets sampled, and the sampled signal is given to the analog to digital converter, analog to digital signals. Okay, so here it's an analog to digital converter. It will convert the, it's an analog signals. So it's a means here it will get converted to discrete signal, so properly it get not converted to digital signal. Okay, so we are using that analog to digital converter. So the analog to digital converter is given that a digital output. So the digital output will get that a digital filter. So the digital filter will get will get the proper that means proper, we want to know the information about the signal, right? So by using this digital filters or DSP system, we will get the knowledge about the signals, and we will get the knowledge about that signals, and how we are getting the knowledge about the signals, because by using that proper digital technique, digitalization techniques, we will get the proper knowledge about the signals, and will the digital signal is given to the digital converter. Okay, so the digital converter will get quantized signals. Quantized signals means it will get organized the signals. That signals get again converted to digital to analog signals. So this signals is again converted to the analog signals, right? So the analog signals is again passed to the analog low pass filter. So why we are using that again low pass filter? By converting from analog to digital and digital to analog signals, there is an some of the unwanted signals are present from analog to digital signals. Okay, analog to digital signals, so we are giving that analog low pass filter. By using this analog low pass filter, it will reduce the unwanted noise present in the analog signals. Okay, so we will get the pure processed analog signals. So we will get an advantages of giving that. Giving means we will get the proper knowledge about the signals and proper informations or mathematical equations about that signals by using DSP systems, and we will get also one processed signals. Okay, so these are the advantages of using the DSP processor, and these are the basic block diagram of the DSP processor. So I think I have explained through in one by one components, so you will get the better knowledge why we are using this to this, what is the why we are using. So you have to know that signals. Okay, you have to know about that why we are using that hold signal, why we are using that sampled signals. Okay, so these are the about the basic block diagram of the DSP. I think you get the proper knowledge about the signals. I think we should move to the next topic. So explanation. The first step is to get an electrical signal. So this is one and for an example from analog to digital, and it is again converted to analog signals, right? So let us I mean understand the through one proper example, so you will get the better knowledge. So the first step is to get an electrical signals. So the transducer in our case is a microphone. So first of all we will take just a microphone. Okay, so whatever things we have, just take that, and that converts the sound into an electrical signals. First it will we are giving that sound in microphone. What we should know, we should do that we will give a sound. That sound is converted to electrical signals. You can use any transducer depending upon the case. So what is meant by transducer? So I think you have studied in control system lab. Transducer, it's well converted from one form of energy to another form of energy. So here we are giving the sound. So the sound is converted to what signal? Electrical signals. So once you have an analog electrical signals, so it is an analog electrical signal because means it's a continuous electrical signals. We pass it to an operational amplifier. So why we are using that operational amplifier? Why we are using that op-amp to condition that means to condition the analog signals, to properly condition the analog signals. Basically we amplify the signals. Okay, or limit to protect the next stage. So for limiting or protecting the next stage. Next, it's an anti-aliasing filter. So why we are using that anti-aliasing filter is an essential step in the conversion from analog to digital signals. It is a before step for analog to digital converter. Okay, so it is a low pass filter, meaning it allows frequencies up to a certain threshold to pass. So in low pass filter it will restrict. So this much amount of frequency will allow, and this much will not allow. So in future classes we will study about the filter. You will get better knowledge about that low pass filter. It attenuate all frequencies above this threshold. These unwanted frequencies make it difficult to sample an analog signal. Okay, the next signal is a simple analog to digital converter. Okay, ADC, right? So I think you have studied in this, that is ADC, analog to digital converter. So analog to digital converter, this unit take analog input and output to the streaming of binary digit. So we will get in the order of zeros and ones. So next we should know the heart of the system is digital signal processor. So by using digital signal processor, we will get the information about the signals by using the digital techniques. What are the digital techniques we are using? These days we use sequence chips. to make digital signal processor. So in fact, modern processor like Cortex M4 having DSP units built inside the SoC. So these are the processors we are using that for the extraction of the information from the devices. So these processor units have high speed, high data throughputs, and dedicated instruction sets. So these are the some of the advantages of using this type of processor. Okay, so the next stage or the sort of the opposites of the stages preceding the digital signal processor. So next opposite stage means next we are getting that information, right? So again we have to convert it from the digital to analog signal. Okay, so that we can use that accordingly. So the digital to analog converter does what its name implies. It's necessary for the slew rate of the DAC to match the acquisition rate of the ADC. So the smoothing filter is another analog low pass filter. I have already told that anti-aliasing lost filter. So I think analog low pass filter. Why we are using analog low pass filter? So here we have getting the unwanted noise in the analog to digital converter. So we have to process get an analog signals. Okay, the last open is just an amplifier. The output transducer is a speaker in our case. So output transducer, what is the output transducer? So it's a speaker. So these are the things are happened in the from the mic to the speaker. So you can use anything else according to your requirement. What are the things you have to know accordingly? You have to need and do it for our requirements. Okay. Next, next is advantages of using DSP. What are the advantages of using the DSP? Okay, yes. First is less overall noise. So by using the DSP, we will get to the we are using the filter quantization technique, digital to analog. We will get an information about the signals. So what are the about the harmonics present in the signals? Okay, by you getting that information, we will detect or correct that signals, right? So by correcting that signals, we will get less overall noise. Since the signals are digital and inherently possess a low probability of getting mixed with unwanted signals, there is a probability of less mixing that unwanted signals. So in the entire system get benefited. So the DSP not really have much noise to deal with comparatively. Next is error detection and correction is possible in DSP. Next, data storage is easier. Next, encryption. Encryption and decryption means already I have explained in the previous class, right? That is multiplexing and demultiplexing. So the digital signals are easy to encrypt. So this one count as a win for the entire DSP system. Two. So these are the some of the advantages of using that DSP. So that is less overall noise, error detection and correction is possible in DSP. Data storage, we can store more of the data in the DSP system. Next, it's an encryption. Some of other DSP that is advantages, that is easier to process, more data transmission, higher component tolerance in DSP. Next, it's easier to modify. That easier to process means the digital signals will undergo the mathematical changes as compared with the analog counterpart. So more data transmission, it can use to transmit the more data over unit time and over a single communication path. Next, higher component tolerance in DSP. So the components like resistor, capacitor, and inductor have a certain threshold in terms of temperature. Outside this threshold, the temperature increase. This may start behaving erratically. Okay, so the components are not present in digital systems. Moreover, the digital systems can increase their accuracy with components like floating point arithmetic. So it is easier to modify. To modify an analog processing system, you need to change components, test, and verify the changes. With a digital signal processing, you need to change a few comments or alternate few lines of codes. So these are the I'm saying this is just an advantages. Just go through it. Okay. By reading this, I think you have understand or getting that more idea about the topics. So the DSP systems can work on frequencies of your border range. So that is there are some natural frequency arrays, seismic frequencies that they detect. So seismograph is normally used to detect the earthquake. So this the seismic frequencies that is detect earthquakes. These signals have a very low frequency. Traditional analog signals might have even detect these signals. However, digital signal processings are adapted to picking up even the tiniest of disturbance and also process them easily. Next, cost. When working as scales, DSPs are cheaper. So while working, so one of the this cost wise, it is one of the advantages of using that system. Next, what are the disadvantages? By using this DSP, what are the disadvantages we will get? That is complexity. As we saw in the block diagram above, there are a lot of elements proceedings and following a digital signal processing. Steps like filters, we are using the filters, converters. What are the things? I think I have explained in the block diagram. There are a lot of components. I think nearly before analog, before the processor, there is a three components. After processor, there is a three components. So it is an extra components and extra complexity. Okay, so it's a extra complexity of using that block diagram. Next, power. So digital signal process is made up of transistor. Transistor, you know that transistor consumes no power, more power, and they are active components. A typical digital signal processing may contain million of transistor. So this increase the power that the system consumes. Next, learning curve and design time. Next, loss of information and cost. Next, what are the applications of DSP? That is audio and speech processing, sonar, radar, and other sensor array processing, spectral density estimation, statistical signal processing, digital image processing, data compression, video coding, audio coding, image compression, signal processing for telecommunication, control system, biomedical engineering, and seismology, among others. So these are the some of the applications of the DSP. Almost they will given that 2 marks questions for applications of DSP. So just go through this topic. So that's all about that components of DSP. I think I have convey as much as possible about that components of DSP, block diagram, explanations with examples, and advantages, disadvantages, and the applications of DSP. So that's all about the components of the system. Thank you.